This is Pre-Calculus, the Functions and Graphs unit. I'm Mr. Stark. In this lesson, which is titled 1A, Solving Equations 3 Ways, we'll discuss the three mathematical models and the zero factor property. Let's check it out. There's pizza involved. First, let's do a little review. I have 6 expressions for you to factor completely. Let's set up a few of them. Number 1 is called a difference in two squares, and it ends up factoring into two binomials. With number 4, all 3 terms have something in common, so you could factor that out first, and then you end up factoring even more. So see what you could do, and the answers are on the next page. Let's talk about mathematical models. There are 3 methods for modeling a real-life situation. There are also 3 ways to solve equations, just like the title of this lesson implies. Before we jot down some notes, let's split up our space into 3 columns. The left column is for the 3 mathematical models, and here they are: numerical, algebraic, and graphical. With the numerical model, we're basically talking about a table that's filled with numbers or data. With algebraic, we're talking about a formula or equations. And with graphical, we're talking about a visual or some sort of sketch. I'd like to check out each one of these methods with you. The middle section is for the algebraic model, and then the right side will be for the numerical and graphical. Here's a situation. We can choose from 2 different shapes of pizza. One is rectangular and one is round. They both cost the same amount of money, so we're trying to maximize the amount of pizza that we get for our money. The size of the rectangular pizza is 20 inches by 22 inches, and the round pizza is a 24-inch diameter. So how do we do this? With a formula. We need to find the area of the rectangular pizza using area equals base times height, or length times width. And we need to use a different formula for the round pizza. Area equals pi r squared. Remember, 2 pi r is for circumference, not area. So here we go. The area of the rectangular pizza is 20 times 22, which is 440 square inches. The area of the round pizza is pi times 12 squared, which is half of 24. So that's 144 pi. Plugging that into a calculator, we get 452.4 inches squared. There we have it. If we want to maximize the amount of pizza that we get, then we're going to choose the round pizza. In the third column, we'll use most of the space for the graph, but here's the table that includes the data that we'll create a scatter plot with. This is the U.S. prison population for females from 1980 to 2005. And since the data includes years, what we want to do is let the first year, or the oldest year, represent x equals 0. We end up writing less, but also if we create a model for the data, then the equation is much more manageable. To create a scatter plot, let's just sketch the x and y axis. Let's label the x-axis year, and the y-axis just population will do. We'll sketch 5 tick marks for the years: 1985, 90, 95, 2000, and 2005, because the first year will just go at the origin, and 2005 is 25 years after 1980. The population goes up to 108, so what I like to do is just put 100 close to the top, but not all the way, and then we could just plot a point above that for 108, and then we could plot 50, which is half of 100, 75, and 25 are in between those tick marks. Finally, we could just plot these points. So 13, 23, 44, 68, 93, and 108. And since this is just a graphical representation of the data, it's a scatter plot, then we don't have to draw a line in between these points. In fact, we definitely don't want to connect them kind of like a zigzag. The best thing that we could possibly do is create a line as a model, or if we think it's some other model like a parabola or exponential or something like that, we could do that. But we're just going to leave it how it is so that we could see the data based on the table. The zero factor property. is the last thing I want to talk to you about. And let's split this section up into two parts, a left half and a right half. On the left half is basically the definition of zero-factor property. The verbal piece says if the product of two numbers is 0, then one of the factors is 0. If those two numbers multiply by each other is equal to 0, one of them must be 0. The algebraic way to say this is if a times b is equal to 0, then a equals 0 or b equals 0. I need to point out, however, that a or b could be more than just a number. It could be an expression, it could be a polynomial, it could be a function. So keep that in mind as we solve equations. Here's an example. X squared minus 3x minus 4 is equal to 0. So we could take any of these equations that we factored earlier on and set them equal to 0 and solve for x. We could factor this polynomial into x minus 4 times x plus 1, because negative 4 times 1 is negative 4, and negative 4x plus 1x is negative 3x. So here we have it. We have something in the form of a times b is equal to 0. The a is the x minus 4, so we set that equal to 0. The b is x plus 1, and we set that equal to 0. Therefore, we have x is equal to 4 or x is equal to negative 1. Those are the two solutions to that equation. Well, that's all I wanted to share with you. Now I encourage you to explore the zero-factor property by setting each polynomial from the review problems equal to 0 and solving using the zero-factor property. In a moment, I'll leave the answers up for you to check your work, but just wanted to thank you so much for watching. See you next time.